next two sections, we're going to use several trigonometric identities and formulas. We're going to start with sum and difference formulas, which are going to allow us to find the exact values of functions that involve sums or differences of our special angles. So remember, with the exact value, that means we don't want a decimal, we don't want approximation. So we're just going to leave the answers exact. And let's start with this example here. We're taking sine of an angle that's not one of our special angles, so it's not going to show up on our circle. If we can rewrite this angle as a sum or difference of two angles that are on the circle, then we can use the sum or difference formula to evaluate this. So a lot of times in your homework, they will just tell you the two angles that are added or subtracted to make up this one. I want to show you if you had to determine on your own what two angles you should use. Here's one way that you could do it. Looking at this denominator being 12, I want to use a denominator that is a factor of 12. So let's say I want, and you want to choose something that's on the unit circle. So looking at 12, I could use a denominator of 2, 3, 4, or 6. All of those show up on the unit circle somewhere. So let's say I want to use pi over 4. I want one of these angles to be pi over 4. To figure out the other angle, you kind of just have to subtract. So the question is pi over 4 plus what would give me 11 pi over 12? So just like solving an equation, if I subtract 11 pi over 12 minus pi over 4, that'll give me the other angle. So 11 pi over 12 minus pi over 4. If I write pi over 4 so that the denominator is 12, that would be 3 pi over 12. So if I subtract 3 pi over 12 from 11 pi over 12, then I get 8 pi over 12, which is going to simplify to 2 pi over 3. So let me show what I did here. This is 3 pi over 12. And so I would have to add 8 pi over 12. And reducing all of those, this is 1 pi over 4 plus 2 pi over 3. Okay. But pi over 4 and 2 pi over 3 are angles that I can find in my unit circle. So I'm going to rewrite sine of 11 pi over 12 as sine of pi over 4 plus 2 pi over 3. And this is not the only combination that could give you pi over 12. So there's a few different ways that you could rewrite this angle. But once we have it written as a sum or difference, we're going to use the formula, and I'll put the formula in here. Very important that you know that you cannot distribute a sign. You cannot just distribute this sign across the parentheses. This is not the same as sine of pi over 4 plus sine of 2 pi over 3. You have to use this formula and has to involve the cosines as well. All right, so in this formula, my u is pi over 4 and my v is 2 pi over 3. So now I just have to evaluate each one of these functions. And these are either values that I know or that I can find on the unit circle. I know sine of pi over 4 is square root of 2 over 2. Cosine of 2 pi over 3 is negative 1/2. And then I got the plus in the middle. Cosine of pi over 4 is square root of 2 over 2. And sine of 2 pi over 3 is square root of 3 over 2. So reference angle for 2 pi over 3 is pi over 3, but we're in the second quadrant, so that'll tell you the signs. Or at this point, you can check on your circle. Now I'm just going to simplify this, so I'm going to try to multiply. So these two would give me negative square root of 2 over 4. These two, so when you're multiplying, if they both have square roots, I can multiply them. If they don't, then I'm going to leave them separate. These two both have square roots. I'm going to get square root of 6. They have the same denominator. I'm going to combine this into one fraction all over 4, and we're going to leave the answer just like that. Don't put it in your calculator. Don't round anything, because then the answer is not exact anymore. In this problem, we're asked to write this expression as sine, cosine, or tangent of an angle. So it's important to understand that this is not asking me to find sine, cosine, and tangent. It's just asking me to rewrite this as just one with one function of one angle. So what we have here is the expanded version of one of our difference formulas. And so if you're looking at it in the textbook, this is the right side of the equation, and we want to put it together, condense it back to get the left side of the equation. So we got to figure out which match this up to one of the formulas. And so this one has cosine times cosine, and then sine times sine. So cosines are together and sines are together. And that's one of our cosines. Some are different. And with cosine, the signs become opposite in the formula. So since this one is subtraction, the other side of the equation would have addition. So here's the formula that I'm matching it up to. The one that says cosine of u plus v. And in this problem, my u is going to be 110 degrees and my v is going to be 20. So I'm trying to end up with just the left side. So they gave me the right side. I want the left side. So this is going to be cosine of u plus v. So that's the cosine of 130 degrees. And that's it. That's the answer. All right, one last example. We are going to use these formulas to solve an equation for x. So here we're going to be very careful about the signs because these almost look the same. And I'm just going to go one term at a time. So first, using a formula to rewrite this, and then using a formula to rewrite this. And then we'll see if we can combine like terms or evaluate something to simplify until we've got just one trig function isolated on this list. All right, so I'm going to use the sum formula that involves cosine. And so this first one's going to be cosine of x times cosine of 3/4. And then cosine does the opposite, so this is going to become minus sine x sine 3/4. All right, so that blue term that I had in the original problem became all that blue stuff in the second line using a sum difference formula. And then I'm going to do the same thing with the second term. And because this is subtraction, I'm going to put everything that I'm about to write in parentheses to make sure that that minus is applied to all of it. All right, so that's what I get using the formula. Still have that equals 1 over there. Now I'm going to try to simplify. So first I want to get rid of the parentheses and apply this minus to everything else. So I'm just going to rewrite. Being very careful since there's a lot to write and a lot of signs to keep straight. Okay, so when I distribute the negative, that's going to make this term minus. Okay, so now remember terms are separated by addition or subtraction. So I'm combining like terms, and these cosines, this one and this one, they're like terms because they're exactly the same. They're the same function, the same inputs, so I can add them together. But one's positive and one's negative, so they're going to add up to 0, cancel each other out. Now with these two, they are like terms. I can combine them. They're both negative, so I'm just going to end up with -2 of them. So -2 sine x sine of 3/4. That should be equal to 1. Now I still have two signs and I just want one, but I can evaluate sine of 3/4. I know sine of 3/4. The reference angle is pi/4, but I'm in the second quadrant. Sine is still positive, and that's going to give me square root of 2 over 2. So now I'm going to multiply the -2 times the square root of 2 over 2. That's going to cancel the -2 and the 2 in the denominator and just leave me with the negative square root of 2 times that sine. All right, so now I've got just one trig function. I'm going to work on isolating it on the left side. So I need to get rid of negative square root of 2, and I'm going to divide it off. So sine x needs to be equal to -1 over square root of 2. This is on my unit circle, but the denominator is going to be rationalized. So I'm going to rewrite it with the rationalized denominator. And then it says sine x is equal to a negative square root of 2 over 2. Sine is negative in the third and fourth quadrants. And the angles that give me square root of 2 over 2 would be 5 pi over 4 and 7 pi. So this x is equal to 5 pi over 4 and 7 pi over 4. Don't have to worry about adding multiples of 2 pi since they gave me an interval and I only want the solutions between 0 and 2 pi. So here's the solution there.